about 1,000-bed children's hospital. It's a very large environment. We're also one of the leading research hospitals in the United States and indeed in the world as well. Our environment's about 180, or considering the installs that I just did last week, probably topping around 190 instances, versions all the way from SQL Server 2000 up to 2012. There are a few places during this presentation where the material that I'm giving you is going to matter which version of SQL Server that you are using, and I'm going to point that out when we get to those specific points. I've worked with SQL Server since version 6.5, so I've been doing this for a while. Fortunately, none of the material that I'm going to be covering in here is actually going to go all the way back to 6.5. I hope we've all upgraded since then. So contact links, you're going to get your fastest response from me if you contact me on Twitter. You'll get your most complete response from me if you contact me via email, and if you want to read some of the other things that I've written either on database performance, or I do a little bit of writing on disaster recovery as well, you're going to find those things, including the scripts and the slides for this presentation on my resources page at dmmaxwell.wordpress.com. So I said we're going to talk about transaction log internals and performance, and the way that we're going to go about that is we're going to start with talking about what's really in the transaction log. It's not necessarily enough for us to just say that the transaction log is a record of all the changes that happen to a database. There's a lot of information that goes in there very, very quickly, and it helps us to be able to understand that information when we're trying to tune something. For example, you're trying to tune a car. What's one of the common places that you want to start? You want to start with the engine. And how do you tune the engine? You need to understand how the engine works, what goes in and out of it. So that's the first thing that we're going to talk about today. The next thing that we're going to talk about is how the log manages all of that information that keeps flowing in and out of the transaction log. Like I said, there's a lot of information that goes in there very, very quickly, and we'll describe some of that and look over that. The SQL Server needs a way to be able to manage that amount of information, and it does it by a process called virtual log files. We'll get more into that further in the presentation. That's a term you may have heard before. We're going to cover those in a little bit more detail and show you what those actually look like. We're going to talk about maybe some potential problems that you might have seen with the transaction log before, and some potential solutions that you might have available to you. And finally, we're going to start digging into performance tuning for the transaction log. How do we make this thing go faster? A lot of SQL Server performance problems that I have seen both recently and throughout my career with SQL Server have been regarding the transaction log and trying to get better throughput out of it. So that's definitely a topic that we are going to dig into a little bit and cover today. So let's answer our first question. What's actually in the transaction log? A lot of things. The log is a record of all changes in the database. And when I say all changes in the database, I'm not just talking about user-initiated changes. Yes, we've got our inserts, our updates, our deletes, create tables, create stored procedure, alter tables, alter columns. All of these things that we can initiate, those are all considered records, are all considered changes to a database, and those are all treated as transactions. But there are other things that go on behind the scenes as well that are considered transactions, things like page splits and indexes, allocating new data pages within a table, allocating new tables, allocating structures within the database, modifying the sizes of database files. There's a lot of things that happen behind the scenes as well as user-initiated transactions within SQL Server, and SQL Server has to track all of that. So as an example, we're going to take an update statement. Again, this is a user-initiated change, but as you're going to see throughout the course of the presentation, just issuing a change from a user perspective can cause other things to happen behind the scenes as well. So for our update statement, we're going to look at it from this perspective. The way that we start is we take this 8K data page where our row resides that we want to update. And again, 8K pages are the basic unit of storage for data files within SQL Server. So SQL Server is going to look up the 8K page where this record we want to update resides, and it's going to read it off of disk and put it up into the buffer pool memory. And once it's done that, it's going to write a record of the change that we want to make to the transaction log, and it does this for a couple of reasons. And this is a process known as write-ahead logging. Write-ahead logging is SQL Server's way of preserving the A and D of ACID compliance. A being atomic, transactions must complete or roll back. Well, if we don't have a record of what that change was, if SQL Server crashes, we can't go back and complete it again, and we can't roll it back unless we know what to roll it back to. So the change must be written to the transaction log to allow us to do that. And the other thing that it provides is the D, which is a durability. So again, if SQL Server crashes in the middle of us writing a change and we've committed that change, but the change hasn't been written back to disk yet. It's only been changed in memory. We need that transaction log record when the database starts back up to tell us what the actual data should be on disk. So once all of that's been completed and the page in memory has been modified, a couple of different things can happen. Now, if we commit that transaction and complete it, all we have to do at this point is write a record in the transaction log that says, yes, this transaction is completed. It is now considered durable. However, if that transaction is rolled back for any reason, say maybe an administrator killed the process or something else interfered with it, maybe it was involved in a deadlock or something like that, a couple of different things have to happen. First thing that has to happen is we have to write what's called a compensation record into the transaction log. This is a record that states, okay, we modified something on a page, but we're going to undo that modification. We're going to undo that and roll it back to the value that it was before. So the page in memory at that point is now modified back to its original value, and then we place a abort transaction record into the transaction log. Now at this point, I want to say a little word about checkpoint. Some of you have probably heard of checkpoint before. Checkpoint is a process in SQL Server that has one job and one job only. Checkpoint's job is to write changed pages, those ones that we've modified in memory. They're also known as dirty pages. It writes those back to disk so that the changes we've made are preserved to disk. Now, checkpoint is going to do that regardless of the state of the transaction, whether that transaction has been committed or that transaction has not been committed and it may eventually roll back. Checkpoint is still going to write those dirty pages back to disk. Okay? We don't need to have a commit or a rollback in order for checkpoint to do its job. So now I'm going to jump over to Management Studio. We're going to take a look and see exactly what these records look like within the transaction log. And I've already created a demo database for us to do that in. And we're going to do that using this function right here, which is fndblog. And notice that fndblog takes a couple of parameters, and the parameters that it takes, are referred to as the LSN or log sequence number. And I'm going to go ahead and run this statement. My mouse does not seem to want to behave right now. And show you what some of these records look like. Okay, now before I get into this, I did say that there's a lot of information that gets put into the transaction log. I don't know if you noticed the size of the scroll bar down here on the bottom of the screen, but I could keep scrolling to the right for some time here, and notice there's a ton of potential columns that we could be writing information into within the transaction log. I'm not going to do that right now. So in SQL Server 2012, we've got about 129 different columns that we could select information from using this function called fndblog. So I'm just going to pull out a few specific ones with this statement right here and discuss those. Now, so here is our log sequence number. This is the ID number of a record within the transaction log. The reason this is important to know about the LSN numbers is it has to do with crash recovery. Crash recovery is a process that happens either when you're starting up a database, so you've restarted SQL Server and your databases are coming back online, or you're restoring a database from backup. These records must be replayed in sequence in order for the database to remain transactionally consistent. When you do a restore or when you start up a database, it goes through this crash recovery process, and it has to go through two specific phases. One is called redo, and the other is called undo. In the redo phase, committed transactions that are in the transaction log but are not or have not been applied to the data file are rolled forward. Those modifications are made and then applied to the data file. And then in the undo phase, transactions that have been written to the transaction log but not completed, if they have been applied to the database, those transactions get rolled back. It does this so that we have a transactionally consistent database at the end of crash recovery. So if you've ever tried restoring a database that was in full recovery mode, you've restored your full backup and you're going along restoring your log backups, but maybe you're missing a log backup, you might get an error message that says you're trying to restore a log backup, but your LSN, your log sequence number, is too far forward. You can't do that transaction log restore until you've done the one previous. And if you're missing that previous restore, you're going to be in trouble. You won't be able to actually complete your restore sequence. So this is why that LSN number is important, because the LSNs have to be restored in sequence and they have to be replayed in sequence on crash recovery. Now, you'll notice we've added another column here. This is decimal LSN, and that is the result of a function that was written by a colleague of mine by the name of Lewis Garrett. And what this does is it takes this LSN, which here is displayed as a 3-part hexadecimal number, and it changes it to a 3-part decimal number. And the reason for this is pretty crazy. I said earlier that fndblog takes 2 parameters, a starting LSN and an ending LSN. So you can actually pass a pair of LSNs to fndblog and it will only give you the records that fall between those 2 LSNs. However, if you're not using this function, fndblog is going to give you as output an LSN that is in hexadecimal. But as input, it will only take an LSN that is in decimal. Thank you, Microsoft, for that little gem. So that's why I've included this column here. And again, as I said, the demo scripts and the slides will be available for download from my website. I'll put that URL up again at the end of the presentation. So you'll be able to get that function and use it. Other important columns in the transaction log: operation and context. Operation, this is what I did. Context, this is where I did it. I'm not going to get into the specifics of what each one of these different identifiers is, but that's what you need to know for now. Is this is what I'm doing, this is where I'm doing it. Log record length and log reserve. Log record length is this is how much data I'm actually storing in the transaction log for the modification that I made. So if I modified the file header, I modified 2,260 bytes worth. Log reserve is the amount of space that SQL Server set aside within the transaction log in case it needs to roll a transaction back. Because remember, if we roll a transaction back, we need to write those compensation records to the log as well. So this is SQL Server being a little bit more efficient, saying I'm going to set aside some space just in case I need to roll these transactions back. Page ID gives us the file number and the page number within that file, again that 8K page, where the modification was made. Slot ID, if there's an individual record on the page that was modified, this will tell us exactly which one it was. Transaction SID is really cool. Transaction SID is actually the SID number of the user in the database that made this particular modification or initiated this transaction. So if somebody comes up to you and says, hey, we think somebody may have truncated a table or dropped a table or modified a stored procedure in production. We don't have any auditing. We're not sure who did it. Are you able to find out who it is? Well, if you have access to your transaction log and that hasn't been cleared out yet, you can grab that SID, come back out here and feed it to the suser sname function, and that will tell you exactly who did it. So I am the guilty party on my home system here. So just a couple more columns that I want to point out, and then we're going to go ahead and move on. So lock information is also stored in the transaction log. If any locks were taken as part of the transaction, you'll get a description and a number here for the locks that were taken for that. And again, we have a description column right over here that gives you the details as it can on specific transactions. So here's the one that says our backup LSN was changed to this particular value right here. So this is the starting LSN of our next transaction log backup when it is taken. And that is good information to know. So I'm going to go ahead and create a table for us to modify. I happen to like cookies, and I know a lot of other people that like cookies, so we're going to create a table all about cookies. And I'm going to look in the transaction log here, scroll down just a bit. So now we're starting to see some places where we're inserting rows, maybe into a clustered index here, modifying some information in a clustered index. I've added another column here called allocation unit name. This actually shows us what was the object that we modified with this particular transaction. And if we scroll down here, you'll see that we get a lot of information. These are all system catalog tables. And what we've done here is we've written the metadata that we need to create that table that we just issued the create table statement for. But we haven't actually created the table on disk yet. We haven't done anything with the table itself. SQL Server does not actually create tables until you start putting data in them. Then it's going to allocate the space and create the table on disk. Another column that I just added was transaction name. You can give transactions names. We'll see an example of that in another example of that in just a moment. I didn't name my create table transaction, but SQL Server goes ahead and notates that here for me so that I can look that up if necessary as well. So let's insert a few rows into our cookies table. I like peanut butter cookies. They're my favorite. Best cookies in the world. And let's see what that log shows now. I'm actually going to do this. And I've added a few more columns this time. So if I scroll down a little bit, I'll see after we created that table and added the information to the metadata information into the catalog tables. Now here I see my cookies table has been created, it's got its primary key, and information is being updated within that table. I can also scroll over just a little bit and find, I'm missing my transaction name column. Broken demo, I apologize for that. Anyway, so you see you see here where the records are actually being inserted into the table. Another set of columns that I've added this particular time around are these row log contents columns. This is the actual data that was inserted into the table in this particular case. So the data is stored in a binary format because it's an efficient way of SQL Server to use it, not necessarily an efficient way for us to use it, but it's very, very easy for SQL Server to replay and undo transactions when the data is in binary format. So these are the actual records that were inserted into that table. Come back out here, take a quick transaction log backup. And I'm going to go ahead and start another named transaction. I'm going to call this one cookie roll. And we'll say for sake of argument that I got a bad batch of peanut butter cookies and I'm going to downgrade their rating to 75 from 100. And, well, I think about it a little bit. No, they really are the best cookie in the world, so I'm going to go ahead and roll back that transaction. And when I do that, this needs to be null. We're going to see a couple of different things. I'm going to come all the way down to the bottom here. So here's my begin transaction. This is where I started that transaction, but you notice I've got two modifications here, which is interesting because I only modified one row. And then down here I've got my abort transaction. Well, as we were saying earlier, so here's my name transaction called cookie roll. So we've modified the column first to a different value, but then we decided to roll it back. So here's our compensation record right here. The second modification is the compensation record. If we look at the row log contents column, 64 translates to a decimal 100, which is the original rating for peanut butter cookies. We modified that to 75, which translates here to 4B. And we rolled that transaction back and said, okay, we're going to modify that value back to 64. Now you notice we don't have a starting value. We're not actually starting with the value of 4B and modifying it back to 64. And the reason for that is compensation records are forward only. They cannot be rolled back. They can only be rolled forward. So as a performance optimization, there's no point in storing a before value. All we need is the after value. So SQL Server doesn't actually bother storing that. And then, of course, since that transaction was rolled back, we have an abort transaction record in our log as well. Let's go ahead and move on to our next topic, which is how the transaction log space is managed. Now, as I said before, SQL Server manages all of that data that's flowing into the transaction log through the use of virtual log files. Depending on the size that you create or grow the transaction log file is, the transaction log file, SQL Server is going to break up that log file internally into these virtual log files, which I'm going to refer to for reasons of efficiency for the rest of this presentation as VLFs. That's normally how you'll hear these referred to as the number of VLFs within your transaction log. So the number of VLFs that you get depends on the size that the log is created or grown at. So there's a formula for this. If your creator growth size is less than 64 megs, you're going to get 4 VLFs, 1/4 of the size of the growth. So if you start with a 20 meg transaction log, you're going to get 4 VLFs at 5 megs each. So from 64 up to a gig, you get 8 VLFs at 1/8 of the size. And I know you don't like people who read slides, so I won't do that to you. But I do want to point out that once you get to SQL Server 2014, things change a little bit. So from SQL Server 2000 to 2012, the formula in this table applies. But once you get to SQL Server 2014, if you have a growth for your transaction log that's less than 1/8 of that current size, you only get one VLF. And this is a performance optimization that we'll see how that works in just a little bit. So for an example, if I've got a 1 gig log file with 100 meg growth, for anything SQL Server 2012 or lower, I'm going to get 8 VLFs at around 12.5 megs each. However, once I get to SQL Server 2014, I'm only going to get 1 VLF at 100 megs. Now, quick warning that I got to let you know, for anybody who's out there running SQL Server 2008 R2, there is a bug in that version of SQL Server. You may want to check and see which build number that you're running. If your log growth is set to 4 gigs, what you'll actually get is you'll get a 32K log growth. It'll complete really quickly, but you won't get as much log space as you thought. The workaround for that is to grow your log by 4,000 megs rather than 4 gigs. So that is definitely something you should be aware of if you are using that version of SQL Server. So how are VLS used within the transaction logs? Well, when we create our VLFs, let's say we're starting with 4 VLFs initially, we have 1 active and 3 inactive VLFs. Now, there's always at least 1 active VLF within the transaction log. And by active, meaning that is the VLF that is being currently written to. So information is going to go into that VLF before it spills over into the next one. Now, when a VLF is inactive, we call it being truncated. VLFs become truncated when one of a couple things happens. First of all of the transactions that are within that VLF have to be committed or rolled back. They have to be completed. And if we're running in simple recovery mode, a checkpoint has to have occurred. So we no longer need those records in the transaction logs because we're running in simple recovery mode. We're not doing point-in-time recovery. We have flushed those dirty pages to disk, so we no longer need those transaction log records. We can truncate that VLF. However, if we are running in full or bulk log recovery mode, we are doing a point-in-time recovery, at least within the parameters of those particular recovery models, and we have to have taken a log backup. Those log records have to have been preserved somewhere for us to be able to roll back or roll forward within the database. So we won't actually clear or we won't actually truncate those VLFs until we've taken a log backup. Now, a log is referred to as a circular log file, so VLFs can be reused. If we've written to the first 3 VLFs and we're starting to write into the 4th VLF, we take a log backup. If all of the transaction information that's been stored in those first 3 VLFs is no longer needed, those 3 VLFs will be truncated. We're still writing to VLF number 4. Once we get to the end of that, if the space in VLF 1 is available, then the log records will wrap around and they'll start writing in the first VLF again. However, if we've written to all of our VLFs and we have no more space available and we're still holding onto that transaction log information, say we haven't taken a log backup yet, the log is going to have to grow. And we're going to get more VLFs based on that formula and whatever size that we've set for growth. So let's go ahead and look at a transaction log and see what that looks like within the log. And I'm going to recreate my test database. And you'll see this creation script. You'll see these database creation scripts within every script within the demo files here, and that's because I want these scripts to stand on their own. There's no setup script that you have to run in order to be able to use and play with these demo scripts. Every single script stands on its own. So I'll start by taking my first full and log backup. And I'm going to use this command dbcc loginfo. One other thing that I should say, I apologize for not mentioning this earlier, is these commands fndblog, dbcc loginfo, these are undocumented commands. Now what I mean by undocumented isn't that there's no documentation out there. Lots of people have written documentation on how these commands work. However, Microsoft has not. So what that means is Microsoft is not going to give you support for working with these commands, and these commands are subject to change from version to version. I think I mentioned earlier that in this particular version, SQL Server 2012, fndblog returns 129 columns. It actually returns more in 2014 and less in 2008 R2 and before. So some of the demos that I have in here, I think there's one specific one, and I'll point it out when we get to it, don't work in earlier versions than 2012. So let's go ahead and look at DBCC log info. And this is going to show us the VLFs that we have in our transaction log right now. So we've got a transaction log size of 4 megs. This was the size that we created it at. This is the size that we've set as a growth. So we've got 4 VLFs at roughly 1 meg each. It's a little bit skewed because smaller size transaction logs, it tends to do that. But we're roughly at 1 meg each for each of these. Important things to notice here, the file ID, transaction log is always going to be file ID 2. That's always your first transaction log file. You may have more transaction log files for specific reasons. We're going to get to that in just a little bit. However, I will say right off the bat that performance is not one of those reasons. You cannot get more performance by creating additional transaction log files. We'll discuss that a little bit more later. Offset within the file for where those VLFs starts, and there's a sequence number here. And that sequence number is going to increment each time that the VLF is used and then truncated. We have a status column here. A status of 2 means that that VLF is active. The status of 0 means that that VLF is inactive or that it has been truncated. So let's have some fun. I'm going to create a table called vacation spots. Places that I've been to, places that I would like to go, places that I would like to go to again. Go ahead and insert some data in there. And if we look at our VLFs, we'll see that we're still in the same shape that we were in before. We're still only using the first VLF, which I'll refer to as number 204. And that's because we haven't actually filled up this much space within the transaction log yet. We haven't yet gone beyond this first 1 meg worth of information. This is only a few rows that we inserted. So now I'm going to do a little bit more work. I'll create another table for my travel diary here, and I'm going to insert about 400 records into it. Now let's take a look and see what our VLFs look like. Aha! So now we've actually inserted enough data into this database that we have a full transaction log. So we've got our transaction log sequence numbers have incremented for every VLF that we've used. The status of 2 shows that all of our VLFs are active. So now we'll come down here and take a transaction log backup. And since we're running in the full recovery mode, this is telling SQL that we've got a copy of those transaction log records now. We no longer need to see them, or we no longer need to retain them in the transaction log, so you can truncate the VLFs that we're not writing into right now. So if I come back to log info, now we'll see we have a status of 0 for the first 3 VLFs. VLF 207, that was the last one that we wrote into, so that is the currently active VLF. So let's do a little bit more work and insert about 300 more records into the database. So if I look at my VLF now, so here's 207. We've wrapped around to the first VLF in the transaction log, and that's become number 208. We've spilled over into the next VLF, which is now 209. We haven't spilled over into this VLF yet, so it's still number 206, and its status is still showing inactive. So now, let's do enough work to cause a log growth. We're going to insert 300 more records. And here's what we see when we get a log growth. So here's VLF number 210. We spilled over into that one next. 207 was already active, and we can't overwrite it, so we skip over that, and the next available VLF becomes 211, 212, and this is where we left off. So now, you see over here we've got an LSN number in yet another format, because that's what Microsoft is consistent. We have another LSN number, and this tells us the LSN that the transaction log, that the new VLFs were created under, because creating VLFs is a modification to the database, so that is considered a transaction as well. Now I mentioned earlier about how many columns that FNDB log returns. The cool part about that is that you can use those columns as filters when you're selecting against FNDB log. So this time I've added the VLS added column. This column is only actually going to be used when you've added more VLFs to your transaction log file. So if I run this select, it's going to give me one record, modified the file header for file ID 2, which again is our transaction log file, and the description tells us exactly what we did. We grew our transaction log file, it's twice its size now, and in the VLFs added column, we get a detailed record of exactly what was created and the LSN records that created those VLF files within our transaction log. So there's our size, our offset, and it's going to give us one of these for every VLF that it created. And I'm going to skip over that for time. Okay. Now let's talk a little bit about troubleshooting. There's a couple of particular issues that we see that at least most database administrators will see time and time again. And a lot of and there's a lot of discussion around these particular issues and how to handle them. And the first one that we're going to talk about is when the log runs out of space. So we've had this out of control log growth, or maybe our log is set to a fixed size, but we filled it up. We can't get any more transactions in this log. This could be a lot of different things. Could start with it being a long-running or an open transaction. Certain types of transactions will hold on to that transaction log, hold on to that VLF, and keep it active even if we do take a log backup. There's a thing called a secondary truncation point. Certain transactions that are system generated, for example, you may have heard of this before, if you are taking a full backup or a differential backup, you can still take a log backup, but it will not truncate the transaction log until that fuller differential backup is completed. Other things like databases that are in availability groups or are being mirrored, unfinished transactions that haven't been replayed on the secondary, those will also hold on to those VLFs and keep them active, even if you've taken a transaction log backup. But sometimes our log backups just aren't keeping up, period, or in a lot of cases, they're not being done at all. I know most of us have probably seen that scenario where we've got a 5 gig database with a 500 gig transaction log. Yes, it's in full recovery mode, and nobody ever set up transaction log backups for that. So what do? We have a couple different options available to us. First of all, maybe we need to increase our log backup frequency. I've seen log backups done frequently as every minute. In a lot of environments that I've been in, sometimes they're done every hour, every 30 minutes, every 15 minutes. A lot of that is driven by your RPO, your recovery point objective. How much data can you stand to lose? How much data do you have to be able to recover? But sometimes that's actually driven by a performance concern. It's driven by how big of a backup do you want to have to take? How big can your transaction log get before it starts becoming a problem? Taking transaction log backups more frequently when you are running in when you are running in a full or bulk log recovery mode will keep your transaction log size down. Your transaction log backups will actually be a little bit faster. Sometimes you got to get a little violent. Sometimes you have to kill an open transaction in order to get it to release its locks and to roll back and let go of the transaction log so that that transaction can be backed up. Sometimes you have to get a little creative and add another log file to the database, maybe in a separate storage location where you've got enough room to be able to let transactions continue processing. Because again, once the log runs out of space, if you can't record any more transactions, transactional processing stops. And there is nothing you can do to get it started again until you give SQL Server a place to write more transaction information. Now there are some caveats to these, of course. Rollback is logged as well. So if you're in a situation where you've run out of space, you're going to need some additional space for rollback. Now SQL Server does have that log reserve where it sets aside some space in order to be able to write those compensation records. Usually that's accurate. Sometimes it's not. So that is something that you do want to keep an eye on. Also, rollback in SQL Server versions 2008 and earlier is single-threaded. So if you had 4 threads doing updates, and it took about an hour for that to run, when you roll back, that becomes a single-threaded operation. Now, instead of an hour's worth of work, you're looking at rolling back for 4 hours. So that is something to keep in mind as well. Really what you want to do is you want to determine what the transactions are doing before you kill any transactions. And there is a way to do that, and I will show you how that works within the demo coming up. I mentioned earlier that having multiple transaction log files does not give you any performance benefit. It absolutely does not. Transaction log files are never written to in parallel. It's always written to sequentially. So there's no performance benefit, but sometimes you need to get a little bit of additional transaction log space in order to let things complete. You do want to remove the additional transaction log files when you're done, when you've taken that log back up and you're sure that you've got all your transaction information preserved somewhere else than on disk. And you would do this by actually shrinking the transaction log and then removing the files that are no longer in use. Second scenario, I'm sure most of you have probably heard of this one as well, VLF fragmentation. Now what we mean by VLF fragmentation is that you have a very, very large transaction log with lots of very, very small VLFs. And how do we get into that situation? Growth settings are wrong. The create or growth size for the transaction log is too small for the size of the transaction log that we actually need. So how do we handle this? We have to figure out what a good growth setting is going to be first, shrink the log down to a reasonable size, and then regrow the log to the size that we actually need. Now, this is the $64 million question here. How large of a VLF should I actually be shooting for? Well, I'm going to give you the universal DBA answer here, which is it depends. It's going to depend a lot on the performance of your storage subsystem, but most of the guidance that I've seen in research lately has said that you want your transaction logs to be your transaction log VLFs to be somewhere between 128 and 512 megs. That's going to depend on a couple of different things. Again, the performance of your I/O subsystem, and also how large of a transaction log do you actually need? And this is where the math comes in. If you take a typical workload for the database in question, replay it on a test server, and see how big it grows the transaction log. Then you can determine an appropriate number of VLFs for that transaction log based on a size between 128 meg to 512 meg, depending on the performance of your I/O subsystem. And from there, you'll be able to calculate what your create and growth size should be for your transaction log VLFs. Again, some caveats to this. You want to watch out for what I've referred to as rubber band logs. So these are transaction logs that get shrunk every night. Somebody set up a scheduled job to shrink those transaction logs down every night, and then they grow again during the course of the day as transactional activity is processed by SQL Server. This is bad for a couple of reasons. One, you're introducing file fragmentation within the file system. You might not have a whole lot of contiguous space to be able to grow those logs, so they're getting spread out all over the disk. The other place that this becomes a problem is, again, I said earlier that when the transaction log file runs out of space, processing stops. Well, transactional processing also stops while you're waiting for the log to grow. I want to backtrack just a little bit when we're talking about determining a good growth setting. One of the things that I'm going to tell you, there are very few absolutes in SQL Server, but one of the things I'm going to tell you is absolutely you should not do is use a percentage as your growth setting. I know that SQL Server's default for transaction log files is to grow them by 10%. That is never good, because what you're going to get with a percentage growth is inconsistent sizes for your VLFs. You want to be as consistent as possible when it comes to I/O, and especially when it comes to VLF size. And you're going to lose a little bit of that if you have these rubber band logs. Delays while growing, again, transactional processing is going to stop while your transaction log files are growing. SQL Server has to wait for that to happen. And the reason that it has to wait is because transaction logs have to be what's called zero initialized. There's a setting in SQL Server called instant file initialization that comes into play for data files, where SQL Server can say, hey, I need another 2 gigs worth of space for this data file. It can just grab that on disk. But where transaction logs are concerned, there's a specific byte pattern that SQL Server uses to mark the end of a transaction log record. If that happens to show up on disk, SQL Server is going to assume that there's this massive transaction log record within the space that it's allocated for the log file. So it has to zero initialize, write zeros all across the disk in the space that it's reserving for its transaction log so that that doesn't happen. So let's look at a couple of specific things here. We'll recreate my demo database again. Thank you. take my full and log back up. So now we're going to create a table called movies. And I'm going to insert some information on various movies that I have seen or would like to see in here. Did not care for Pitch Black. We can discuss that offline if you want to. And I'm going to start a named transaction called Bond, James Bond. Okay. Actually, I'm going to insert a record for movie Spectre. And I want to look here. And by using a couple of specific DMVs here, the first one is DMTran database transactions. So this ties transaction log information records back to a specific database. And then there's DMTran session transactions, which ties that transaction log information back to a specific session. So we join those to the sys.databases and sysdmexec sessions views. And it shows us some good information. So we know what database the transaction log activity is in. We see the session ID, the username, what time the transaction started. This is important. This can give us an idea of how long a transaction will take to roll back. The number of records that were created in the transaction log for this particular update. Now here we're only updating or we're only inserting one record. But as our results show us, we have two transaction records. That's because the begin transaction is considered a record as well. And then transaction bytes. How much space are we actually taking up in the transaction log? So if you've got a lot of transactions on your system, very heavily transactional system, this can show you where your biggest transactions are at, what sessions are using them, what user is creating those big transactions. That can give you somebody to call, and you can say, hey, what are you doing? Is it important? You're causing problems. Can I please kill your query? So now let's commit that transaction. We're going to have Mr. Bond committed. And if we look again, now we have nothing. The reason for that is that these DMVs are only going to show you currently active transactions. It will not show you previous transaction information. Once the transaction is committed or rolled back, there is nothing for these DMVs to show. So that is how you can determine what transactions are active on your system if you're looking for a transaction to kill. Now, this demo takes a moment or two, so I'm going to go ahead and get this started. Recreate our demo database, and I've created this with a 16 meg log that has a growth set to 16 megs as well. So what this is going to do is it's going to grow this transaction log out to 2 gigs, but it's going to do it 16 megs at a time. So we're going to get, for every growth, since we're below 64 megs on our growth size, we're going to get 4 VLFs at 4 megs each. And hopefully this shouldn't take too long. There we go. So it took about 20 seconds or so for us to do that. So here's a couple of commands that we can use to examine the transaction logs. The first one is, again, FNDB, or not FNDB log, is DBCC log info. And if we scroll all the way down here, we've got nicely sized 4 meg VLFs, and we should have about 512 of those. So that's 4 megs. All the way up to 2 gigs, we have 512 VLFs. That's a lot. The other command is dbcc SQL perf log space. What this does is it gives you a quick overview of all of the databases that are on your system, the size of their transaction logs, and how much space is actively being used in the transaction logs at this time. So for our Turbo T-Log database, we've got 2 gigs worth in size, but we're only using about 0.8% of the space. So let's fix that. So what we want is to shrink that file down back to its original size, and then we're going to regrow that file out to 2 gigs, but we're going to do it with one growth rather than a bunch of little 16 meg growths. It's going to take roughly about the same amount of time, but the results are going to be very, very different. Since we're over that 1 gig limit, we're actually going to get, if I remember my formula correctly, we should get 16 of those. So here's our first 4, and then we're going to get 16 of those at 1/16 of 2 gigs. Much more manageable, much easier for SQL Server to use. Now, here's where things start to get fun. Improving log performance. So, when we're talking about transaction log performance, we're really talking about write speed. Now, disks tend to be pretty easy to read from, but pretty difficult to write to. Write latency is always much more of a problem than read latency is, especially in highly transactional systems. So, we want to start by improving overall I/O. How do we do that? Faster disk is always a great place to start. If you have access to something like Pure Storage or a SanDisk array, and by the way, I'm not getting paid by either of those companies to say that, but Flash is a great option when it comes to transaction log files. If you're still using spinning Rust, or what I would call, old school hard disks, SATA drives, if you're on the SAN somewhere, make sure that you're getting the best throughput that you can. Talk to your SAN administrator. Find out what RAID levels that you're using to support your SQL Server workloads. We all know RAID 5 is a bad choice for transaction log files. RAID 10 is better. The larger number of spindles you can get, the faster your writes are going to be. Another thing you want to keep an eye out for is file fragmentation. Again, we talked about those rubber band logs. Those can get scattered around the disk because of that constant shrink, grow cycle. You want to definitely avoid that and try to keep those files contiguous. Now, as far as the physical file fragmentation is concerned, it's not as much of a problem as something like slow disk would be. However, it is something that you do want to keep an eye on. You might get somewhat better performance depending on how fragmented those files are across the disk. I've seen anywhere between 20 to 30% performance gain just from defragmenting log files. Again, in some cases that's not going to be very much for you, but it is something that you do want to keep an eye on, especially if you're seeing those rubber band logs. Random versus sequential I/O. Different file types within SQL Server have different usage patterns. Data files tend to be maybe 80% read, 20% write. Transaction log files are almost 95 to 99% sequential write. So what you're looking for is very, very quick write throughput. Now, a lot of us have seen some guidance from various places around the web, from Microsoft, that will tell you you want to split your I/O workload. You want to have your data files in one location. You want to have your log files in a separate location. So what happened is a lot of people went out and they created their servers and they said, well, okay, I want to have all my data files on my D drive. I want to have all my log files on my L drive. I want to have my tempDB files on my T drive. Well, the problem is if you've got all of your log files on one drive, that's random I/O because you're writing all over the drive to hit all of these different log files. If all of your databases are very chatty, you might want to consider isolating those log files to different storage subsystems. Now, if you've got one database that's really chatty and your other databases aren't so much, then it may be okay keeping those log files on the same I/O system. But you're going to want to pay attention and look at the latency. You're going to want to look at your wait statistics. You're going to want to look at the things that would indicate whether or not you've got slow I/O for your log files. Pre-allocate the log. We discussed this when we were talking about VLF counts. You want to allocate your log in a size and with a growth rate that's going to give you VLFs that are a reasonable size. Again, we talked about 128 megs to 512 megs, depending again on the performance of your I/O subsystem. If you've got a slower I/O subsystem, you may want smaller VLFs. Slightly faster I/O subsystem, you might want larger VLFs. Auto grow for log files is great as a fail-safe. I would not count on it as a method to manage my log files. You want to be as proactive as possible when it comes to growing these files. You want to try and maintain a decent amount of overhead for those files. Keep an eye on your workload. How fast do those log files actually fill up? And try to keep a good overhead in those log files, whether it's 20%, 30% space. Keep an eye on those and see how fast they tend to fill up, and give yourself enough room to grow. A good example would be is if you were to miss a transaction log backup. How much space would that actually take up in your log files if you miss that transaction log backup? It's going to be different from database to database, but it's something you definitely want to keep an eye on. Another way you can avoid that is to do less work. And right now you're probably thinking, okay, what in the world do you mean by that? Well, let me show you. First thing I'm going to show you is when it comes to VLFs, size matters. So what I've done here is I've created two databases, both with 2 gig log files. The one I grew 16 megs at a time, the other I grew right out to 2 gigs. So if I use dbcc log info to show me the number of VLFs in each file, we'll see that for my first one, I've got, okay, this one has a much smaller VLF size. This is about a 1 meg VLF, and I've got 2,048 of those. And down here, I've only got 16 for that log file. So now what we're going to do is we're going to force these databases to go through crash recovery, and we're going to have a race. I'm going to set both of these databases offline. Then I'm going to bring them both back online, and we're going to see how long it takes each database to come back online. Again, one with 2,000 plus VLFs, the other with 16 VLFs, but the same amount of space and the same amount of transactions, which in this case is 0. So, of that 12 seconds of silence that you just got to enjoy while those things were running, 11 and a half of those were the result of having way too many VLFs in that file. Look at the difference between the startup times in the two databases. Again, we're talking about the same size of transaction log file, but a lot more VLFs, because SQL Server has to look at each of those VLFs to see whether or not it was active and whether or not it needs to look in there for transaction information to recover. So even though we're talking about reading the same total amount of information, more VLFs means we have to read through it a lot slower than if we have fewer VLFs. And then finally, when I say do less work, here's a way that we can avoid doing additional work in our databases. So if you've been a database administrator for a while, the words index fragmentation tend to set you on edge just a little bit. We know for a fact that index fragmentation tends to drag down performance, tends to be kind of a pain in the tail. Some of us are rebuilding our indexes on a regular basis. Some of us are doing it every day. Some of us are doing it every week. Now, rebuilding indexes is one of those things that actually generates a lot of transaction log information. There's a lot of data movement that needs to happen within SQL Server in order to rebuild an index. So what I've done is I've created a demo table here called Fragment Me. And if we take a look at it right now, we see that for our Fragment Me table for the clustered index, we've got 0% fragmentation and an average page density of 99%. So every one of those 8K pages is about as full as we can get it. So now I'll take a log back up, clear out the transaction log, make sure all my VLFs are truncated and available. And I'm going to insert about 1,000 more records into that table. So now let's take a look and see what my fragmentation looks like. That's pretty ugly. So from 0, we've gone all the way up to 98.90, almost 99% fragmentation, completely fragmented. And our pages, instead of being almost 100% full, are now only about 60% full. That actually generates a lot of transaction log. So we generated almost 6,000, a little over 6,000 transaction log entries. And for page splits, which is what's happening in the background, SQL Server is having to split those pages apart so that it can insert records into the table where they need to go. We had to do that 147 times in order to insert those records where they needed to be within the index. So there must be a better way, because we can't not insert data. So we're going to truncate that table, put our original 4,000 records back in there, and we're going to rebuild that index to get rid of the fragmentation, but notice that this time I'm rebuilding it with a fill factor of 60. So I'm telling SQL Server, yeah, I want you to leave a little bit of extra space, which is going to take up a little bit more space in the data file, but it's going to give us room to insert more records. Clear that log out again. Now, when I insert my additional 1,000 records, and I go back and check my index fragmentation, much better than it was before. Only 1.6% fragmentation instead of almost 99, and an average page density of 74, which is actually better than what we started with. So what effect did that have on our transaction log? We only had to write to the transaction log about half as much as we did before. And less writes means less work, it means less I/O, it means things go faster. And we only had to do about 2 page splits this time. And I forgot to grab the log size before, but another benefit of this is because we're writing less to the transaction log, our transaction log backups are actually going to be smaller, which means they will also be faster. So that's an additional benefit to configuring our indexes properly. And that's what I meant by do less work. There are other ways, of course, to do that as well, but that I think is a fun example. So before we close out, I definitely want to say thank you to everybody who took the time out of their day to come and listen to me rattle on about transaction logs for a little bit. I do have some resources to share with you, and these are active links within the slides if you download those from my website. SQL Skills, of course, Paul Randall, Kimberly Tripp, Aaron Stellato, Jonathan Casillas, Glenn Berry. Experts on SQL Server, lots of information out on that blog about how the transaction log works and in the internals of it, far more than I could cover in a session, far more than I could cover in 10 sessions. There's also a book from Redgate Press called Transaction Log Management, written by Gail Shaw and Tony Davis, that provided some of the source material for this as well. Fantastic book on how to manage your transaction logs, how to set your growth settings, how to manage log backups. Lots and lots of information in there. Very good, and I recommend you check it out. You should be able to download that for free as an ebook from Redgate's site. And again, you can contact me. You get your fastest response from Twitter, your most complete response from email, and if you want to read some of the other stuff that I've written or download the demo and slides from this presentation, you'll be able to get that at dmmaxwell.wordpress.com. We got any time left for Q&A, Leslie?
Yep, we've got a few questions on board. Can you explain why RAID 5 is not a choice for transaction log files?
Exactly. RAID 5 is really a poor choice for transaction log files because there's what's called a write penalty to RAID 5. RAID 5 is a construct of where you've got, let's say, for example, you've got 5 disks. 4 of those disks, you'll stripe the data across, but on that 5th disk, you have to calculate and write a parity bit so that if one of those drives fails, you can reconstruct the missing data using the other 3 drives plus that parity information. What that means is for every write that you do to your transaction log, you're actually doing 2 writes. One to write the information to the stripe, and the other to write that parity, to calculate and write that parity bit on RAID 5. So you're actually doubling the number of writes you have to do when you write to the transaction log. So that's why RAID 5 is a poor choice for transaction log. You don't get that write penalty on something like RAID 10, or if you're using a mirrored pair of disks, RAID 1 or RAID 0. Actually, I don't recommend RAID 0. I shouldn't have said that. RAID 1 is definitely better than RAID 0. RAID 10 is better than all of those because you don't have to calculate and write that parity bit as well.
Super. Okay, another one here. Heard of something called a log buffer and that it's 60K in size. Can you tell me briefly what it is and how it relates to, say, a VLF?
Okay, log buffer and VLF are a couple of separate things because VLF can be, any one of multiple sizes. What the log buffer is that is a section of SQL Server's buffer pool memory where it is holding information to flush into the transaction log. It is 60K in size, which is a little bit funny. You would expect, 64K would make more sense, but I actually had a discussion of that with Paul Randall, who said that he actually called somebody at Microsoft to say, okay, why did we set this to 60K instead of 64K? And they cracked open the source code for SQL Server, and the guy called him back and said, well, I didn't comment the code, so I have no idea. So, which was a little bit comic.
Great.
But yeah, so where you can run into trouble with that, if you look at your weight statistics, which is something actually that I need to add to this presentation, and I will be doing that in a future version. When you look at the weight statistics on your servers, you may see log buffer weights. That is because you have got slow writes to your transaction log. It's not able to flush that log buffer out as quickly as it needs to. So your transaction information is actually waiting to get to the log buffer before it can get to your transaction log. So that might be an indication that you've got a really highly transactional system, and you might want to look at improving the performance of the I/O for your log files as well.
Okay, and now this goes back a little earlier in your presentation. Even though I take transaction log backups every hour and a daily full backup, I'm having 549 VLF files in the transaction log, and the size keeps on increasing.
Okay. What I would be curious to know in that situation is, okay, so you're taking a full backup every day, log backups every hour, transaction log size keeps on increasing, you've got hundreds of VLFs in there. One of the first things that I would recommend that you do is actually make sure that you increase your growth size of the transaction log file. Look and see how big that transaction log file actually gets at the end of the day and try to pre-size it to that specific size. So that will do two things. By picking a larger growth size, that's going to cut down on the number of VLFs, and then by going ahead and pre-growing it out to the size that it needs to be at the end of the day, that'll allow you for better transaction throughput because it won't have to wait for those log growths in order to get through all of the transactions that are being written to the log. So that's where I would start. Now, if you do that and you find out that your log keeps growing even after that fact, what I would start looking for is I would start looking for some of those secondary truncation points. For example, if that database is using mirroring or it's in an availability group, or if you're using replication, or you've got very, very long running transactions in there, you can use the demo queries that I have in that particular demo to pinpoint what queries are running and using the transaction log right now and how long they've been in there and when they started. You may have transactions that are just hanging out in there and just never completing. You may need to go in and investigate those and potentially kill something like that in order to be able to get SQL Server to let go of some of those VLFs so that you can actually take those transaction log backups and clear out that space, truncate the transaction log so that it'll maintain a consistent size. But that's where I would start with a situation like that.
Perfect. And we've got one last question. Can you pull the actual date time of the operation that was captured for create table?
You pull the actual date time. That is an excellent question. I'm going to jump back to SQL Server Management Studio for just a second. And I'm going to come back here. Live demo without a net. So this is either going to work or it isn't. And if this takes longer than 30 seconds, I will say I will take that question for research and I will put up a blog post about it.
Okay.
Can't drop because it is currently, okay. I know what's going on here. I'm stepping on my own feet. You know what? I will take that question for research and I will put a blog post up about that one. So that was, can you tell the date and time of creation within the transaction log? For a create table statement, okay, now that I'm thinking about this, for a create table statement, you could do that, or if you go to the sys.tables catalog view, I believe it should have the date time of the creation of that particular table in there. So one of those two locations should be able to tell you. I'm curious now to see if that actually shows up in the transaction log. I'll definitely take that as a research item and get back to everybody on that.
Great, that's fantastic. Lots of thank yous from the participants, and I appreciate everybody joining us today, and that's all we have. David,
thank you. I appreciate your time.
Great. David, have a great day.
All right, thanks. You too.
Thanks. Bye.